A very good evening and a warm welcome to the virtual internship program in data science. I am 𝗖cie𝗺𝗺𝘂𝘶𝗆 and I'm a senior developer advocate with OpenWeaver. OpenWeaver and ICT Academy are very proud to collaborate and jointly launch this unique virtual internship program. OpenWeaver is a SaaS technology company and an application development platform that supports millions of students and developers in building scalable applications with the use of open source. As a part of our community initiatives, we are conducting this internship program to support students such as you gain industry ready skills through project based learning. ICT Academy, an initiative of the Government of India, state governments, and industry, is a not for profit autonomous organization focusing on improving the quality of students passing out of institutions in India to make them industry ready and immediately employable in the ICT industry. The inaugural batch of this virtual internship program will have around 40,000 graduates from over 370 plus institutions across India. This program will provide a unique project based internship experience through live boot camps, mentoring sessions, and an industry ready capstone project in domains such as artificial intelligence, data science, generative AI, web development, and full stack development. This internship will help you differentiate yourself in the job market, improve your technical proficiency, and complete an industry ready project to showcase on your resume along with your skills. Here are some key highlights about this internship. It's a 4-week project based internship with 3 like boot camps, coding projects plus capstone project. You can create and showcase your own industry ready application at the end of the program. It's a fully digital and flexible program to accommodate your academic schedules. You can earn badges as you progress and get a verified certificate on completion. You could meet and collaborate with peers from across 350 plus colleges. So, this calendar will help you follow through the deadlines of your coding projects, live bootcamp sessions, schedules, etc. There are some mandatory requirements that you need to fulfill. So it is important that you attend the sessions live so that your attendance is marked, for which you have to sign in and sign up onto the community or your internship hub platform. And then you have to actually finish your week's coding project, for which also you need to score 60% minimum score. The third requirement is your capstone project that you need to develop as a real-time application, ready to use application that you could build on Studio. So with these three, you are able to accomplish the important requirements, and then it is important that you also check out your internship hub. This is the space that will help you with getting information on the internship program, details of the live bootcamp, as to how you have to finish your coding exercises, ask your queries on this platform. Everything that you need is available here on this internship hub. So, with this thought in mind, let's get started with week 2 of our internship in data science with this second live bootcamp on data analysis using pandas and NumPy. Develop a movie recommendation application. I will now invite and hand it over to our mentor for today's session, 𝗖cie𝗺𝗺𝘂𝘶𝗆, who is also a senior developer advocate at OpenWeaver.
So good evening, participants. I welcome everyone for this virtual internship program on data science week 2. Let's continue to some of the session rules. So be punctual. So join to the online session on time so that we can able to have the sessions from the beginning itself, and then test your technology. Since you're doing the kit and setup and everything along with me, so you have to have your laptops ready, internet connection, everything set, so that you can do do the project along with me without any hesitations. And then you can participate actively, so engage your discussions, ask questions, and actively contribute to the learning experience, so that you can take the full advantage of this entire session. And then follow the instructions. So listen carefully when I'm guiding you through setuping the kit and then installation procedure, and when I'm explaining the code. And minimize your distractions, so find quiet, so that you can able to concentrate on the session fully, and you can able to get maximum out of it. Timely submissions. So of course you have project submissions every week, so you have to do the assignments and submit it on time. And the last date for submitting your week 2 assignment is going to be September 2, so that we can able to evaluate it and release batches for you. Let's jump into the today's session outline. So today we are going to see a open view, open in our open viewer. We are going to see the overview of Python libraries for data science, like your pandas, NumPy, and ACI, and all. And then we are also going to see movie recommendation system with some code snippet and implementation of your candy kits for your movie recommendation system. So let's get into. I'll be sharing the screen and showing you the your hub so that we can get into the remaining topics. Yeah, this is your for the data science. This is your hub page. You'd have already know about it. You may be viewing this by clicking this link. So when you click on this, you will be getting this community page for week 2 live bootcamp. You must be viewing this video from this link only. Maybe later on, if you'd like to see this video and set up the kit and learn anything, you can come back to this page and you can also see this video for later practice. And this page is also containing all these introduction to our week 2 and which contains some of the learning objectives. So in this week 2, we are going to see some coding projects as well as the movie recommendation system. And the major learning output or the objectives of this particular live bootcamp is have a good knowledge, working knowledge on the fundamentals of data analytics and learn various concepts involved in building the recommendation systems such as collaborative filtering mechanism using the pandas and numpy library, and have a fully functional movie recommended prototype that you can customize and fine tune and enhance its performance by adding your own creature into that. And you can see you know, in order to record your attendance, I can see many of you are asking that how to mark attendance and all. So in order to mark your attendance or your attendance needs to be registered, then you have to you can see here in the right corner, if you click on this square button, you can see your name, so that it shows that you have registered with us and then you're viewing this live bootcamp. Once you registered, your attendance will be automatically marked. There is no any separate attendance marking system for this. So only thing is you have to sign into this page and watch the bootcamp, even live or recorded. So this is our Candy one click kit. So you can click on this and set up it. I will take you through this process. And then you can see some of the coding snippets for today exercise, pandas data from two joins, and for sorting, removing the duplicates and all. I will take you through all of these exercises today. And you can see there is a coding project. So every week you will be doing a coding project. Last week also you did the same, and for this week you also have the coding project. When you click on this coding project, you can see that there will be a form loaded. This form will be asking you to enter your full name, email address, phone numbers, and all the details are mandatory. And this will be having some 5 multiple choice question. Along with this 5 multiple choice question, you will be having some 5 more program based question, project based question, which is some of them are related to the kit that we are learning today, and some of them are general in today's topic. So for these questions, you have to just read the instruction and you have to do the program and you have to record the output, and that screenshot you have to submit over here, and that screenshot should be in a png format. Only png format will be acceptable, and no other formats or typing something will not be considered as a correct answer. Okay guys, so once you've done that, you can able to submit it. So if you submit this coding project, then you will be receiving your badges for this week too. So in order to earn the badges, you have to answer 6 questions correctly out of 10, so that you can able to you will be eligible for earning your badges. Suppose if you didn't give 6 correct answer, then you will be receiving a mail stating you to take reassessment, so you can able to retake the assessment and get your badges. So once you submit this coding project, you have to wait for 48 hours. Within the 48 hours, you will be receiving your batches, guys. So here in the bottom of the page, you can also see some of the polling questions. So you can take up this. Already I can see there are 31 voters and all, so that we can able to understand how familiar you are with the data analytics. So this is our community page. Now I'll be taking you through the setup of your Candy one-click kit. So if you're all doing along with me, so from our community page, you can see there is a Candy one-click kit. Click on this particular link. That will ask you to redirect you to this page. So this is our movie recommendation system kit page. So when you click on this one-click kit installer, you can see there is a file getting downloaded. So it's already downloaded. So I'm clicking on this file. You can see it is a kit installer. I'm right clicking on this, extract all. So when I'm giving extract all, you can see there is a batch file. I'm just clicking on the batch file. It may ask you this. You can give run anyway. So once you click run anyway, it will take some time to set up this kit into your systems. So let it be setting up. We will be coming back to this and we will see the today's content. Okay. So today we are going to see some of the important Python libraries that are used for your data science, isn't it? So last week I have taken through basic concepts in Python programming, and now we are going to see some of the Python libraries, advanced libraries that are used for data science applications in order to develop data science projects, in order to do some data science related applications or anything. You have to be familiar with these libraries, so then only you will be good at developing such end up with such applications. So let's get started. So main popular Python libraries that we are using is, first one is NumPy, and second we also have 𝗖cie𝗺𝗵𝘁𝘆, pandas, and then 𝗖cie_kit_learn, and these are all the major popular Python libraries. And there is also some of the visualization libraries are there. So what are those visualization libraries are? Matplot libraries are there, 𝗖cie_𝗺𝗵𝘁𝘆 is there, and there are much more. Okay, so these are all some of the major Python libraries that we are using in day by day, in everyday basis, in order to develop your data science applications or anything. Okay, so let's go into the detail about it, and let's talk about each one of this library. So first we'll start with pandas. So here in pandas library, we can able to add the data structures and tools designed to work with the tables like data. Like whatever the table like data, let's say it is going to be a CSV file, let's say it is an Excel file or CSV file, something like that. Any kind of a huge table format of file, then we can able to process those table format of files with the help of pandas. So we can provide the tool here. It can provide the tools for data manipulations. So what are all actions that is related to data manipulations? So either we can able to reshape the data, we can able to sometime merge the data, sorting the data, slicing the data, and aggregation. So these are all some of the actions or the operations that we can do with the data manipulations. So let's give you an example on data reshaping. Maybe you will be having a huge data set with let's say some 10,000, 20,000 rows and columns of huge data set. Okay, maybe sometime you don't want all the rows and columns to be get processed. You want only some two rows or two columns to be processed at the time, at this time. So in that way, we can able to reshape your entire Excel file or table into some other format. So that is what reshaping. So let's talk about a student database. A student database is containing a student's roll number, student's register number, and their name, and their mobile number, their email ID, their address, marks in every single subject, total marks, average, number of arrears, and total percentage, CGPA, and all the complete details. I maybe have it in my database. Okay, but at present, I want only student name and phone number. So what I can do, I can just create a new table or a new database, which is just a subset of this, which will contain only the student name followed by their phone number. So that is your reshaping. You can have the huge data set, whereas you wanted to make it into a new shape where you don't want all the complete information. You want only the necessary files to be processed, so we can able to reshape or recreate some other table which will contain only necessary information. So that is your reshaping. In some situation, you maybe need a data set. You want to merge some two files. Let's say I am having a data set of a student database of let's say second year students. Maybe some other professor is having a data set of the complete third year students. Now we wanted to take one program which is commonly for second year as well as third year. So we wanted to take the student count and from where the students are coming, what is their way of commutation, and all those details we wanted to assess before we arrange this course. So in order to do that, there is one CSV file, one Excel file which is there for second year, and there is one more Excel file which is containing the details of third year. So now I'm going to conduct a collaborative program which is commonly for second year as well as third year. So now what I will be doing, I will take both the CSV files, both the Excel file, and I'll be merging all these two files in order to create a new file, where the new file is going to contain all the information, total number of students belongs to second year, third year, and their contact number, and from where they are coming, and all the details I'll be getting in my hand. So that is possible only when I'm doing my merging process, isn't it? So there are a lot of need. There are many time you will be in a need of processing your existing file. So the file or the data set will not be in an exact format what you need. So sometimes we have to process them, sometimes we have to reshape them, sometimes we have to create a subset from them, sometimes we have to merge them, sometimes we have to sort them. So it's all the processing that we have to do it with the help of these libraries. Okay, so I was telling you two different examples for reshaping as well as merging, isn't it? So now there is one more thing which is sorting. Maybe sorting is always helpful when we do allocating some resources to each of the student, or anything, calling the students one by one, or anything for any purpose. Sorting is necessary. You are finding some student, then first we have to sort them, and then it's easy for them to find only in a specific range. If I'm searching for some student and their name starts with V, so it's not necessary to randomly search everywhere. I can straight away go in the bottom of the Excel file where V will be there, and in V there can be some 10 to 8 to 10 students will be there. From that I can able to easily find it. Okay, so that's how the sorting is going to be help you for searching, for the making searching process easier. And then there is also slicing. So slicing is something that you can able to um, cut off the data, or let's say minimize the data, something like that. Let's say you have the data, the roll number of students starts from 1 to 1000. You want only top 100 students. So that time there is 1000 number of students, and you wanted to take only the first 100 students. So in order to do that, you can able to do apply the slicing operation, and you can able to slice the data set into from 1 to 100 alone out of 1000, and you can easily use the data. Okay, and we can also do the aggregation again, grouping. So we can able to collaborate or group, aggregate the different data into a single one, and you can make use of it. Okay, so these are all the different kind of manipulations, data manipulation, that we can able to do it with the pandas library. And it can also allow you to handle the missing data. So what is missing data? How your database will be ended up with missing data? There is a chance that when you are collecting the data from the user may be miss out some values, unless you keep all the fields mandatory. And big people maybe end up with giving some missing values. Maybe you will be creating a Google form where the form is asking you to fill your name, roll number, phone number, and all that. If I didn't keep some of the columns mandatory, I didn't keep something as mandatory, then the user maybe leave those columns without filling it. Or sometime they will be filling it with zeros, or they will be filling with null values and all that. So the all that may happen. Okay, so how we are handling this missing values? Any ideas how can we handle this missing values? Let's say I'm asking you to enter your basic details, basic, very very basic details. I'm asking your name, I'm asking your age, I'm asking your phone numbers and all that. And the age field is not mandatory, so some of the students have entered their age, some of the students has not entered their age. So how can I deal with this? I can see there are many students posting that we can able to take a mean of all the available values. I can see dropping the rows, and then or by filling them. Okay, good, yeah. So we can have many different options, like either I can able to predict the age value of the students, because if I'm just sending the forms to only the second year students, so let's say if all of them are in the same age group, then what is the other person's age, then I can able to fill this person age also with the same value, because they all belongs to the same year. Okay, maybe one or two exceptional cases will be there, otherwise everybody will be in a same age group. So I can able to take up the same age group of the other persons. Or let's say if your data is of huge range, let's say your data is going to be of 10,000, 20,000 students, then dropping one or two values will not make that huge difference. So I'm just dropping some of the one or two value or students entries. It's not going to make a huge difference, so I can drop them. Otherwise I can fill up with mean value also. I can take up the mean value or average value, then I can fill up that. So that is one possibility. And all I can also drop the values, that is also another possibility. But if the number of data is very less, then dropping the data is going to make a huge difference. Let's say I'm having only 10 datas. Out of this 10 data, if I'm dropping two of the data, then it is going to make a huge difference, so I can't able to drop the data. Okay, so it's up to the number of data. If it is huge, then dropping is not a problem. If it is, let's say if it is going to be a small data set, then you shouldn't drop the values. You have to just fill up with all other values, like mean value, or with the other person's age or something like that. We can able to fill up the data. So this is how we can able to handle your missing data. Next, the other libraries, like we have NumPy, we have 𝗖cie𝗵�々. So NumPy, it's introduces the objects for multidimensional arrays and matrices, as well as the functions that allows us to easily perform advanced mathematical and statistical operations on those objects. So we can able to perform advanced operations and statistical operation with the help of NumPy, and provide vectorization of mathematical operations on arrays and matrices, multidimensional matrices and all. We can able to easily do it with the help of NumPy. And we also have 𝗖cie𝗵�々. So this is collection of algorithms for linear algebra, differential equations, and numerical integration. And we can also do it with optimization, statistics, and much more. Okay, so these are all different famous libraries that we have in Python for data science. And we also have matplot library, 𝗖cie𝗺𝗺𝘂. So matplot library is one such huge powerful library that is used for 2D plottings, a set of functional similarities of MATLAB, like how MATLAB used to perform it. It is similar to that. We can able to do the line plots, scatter plots, bar charts, histograms, pie charts, and all these kind of visualizations and all easily possible with the help of matplot library. So when you have your CSV files or any kind of a data set, then by using this matplot library, we can able to come up with nice visualizations about your data, what your data is trying to say, what your data is saying to us, what are all the patterns that are there, what are all the similarities, and all this insight we can able to get from this, we can able to create from this matplot library. And we also have 𝗖cie𝗺𝗺𝘂. So this is again based on this matplot library, which provides high level interface for drawing attractive statistical graphs. Okay, so these two matplot library and 𝗖cie𝗺𝗺𝘂 is purely for creating visualizations. So Python libraries for data science. So here we have seen, I think, many of the libraries, like we have seen pandas, we have seen numpy, and we have seen matplot library, and we have seen 𝗖cie𝗺𝗺𝘂. So there is last and one more important library that we have is ACI kit which provides the machine learning algorithms whenever we are doing some kind of classifications kind of a task, or some kind of a regression related task, or clustering and model validation. So these kind of machine learning related tasks, if you are doing in your project, then it is better you can go with the ACI kit. Okay, and this is built on numpy and ACI MATLAB. It's built on top of that. So today, so this is some of the basics about what are the different basic data libraries that we have written Python for data analytics. So now we'll be moving on to the OB recommendation system using pandas. So now I'm going to introduce this new concept which is called as collaborative filtering. Guys, anybody already know about this? What is collaborative filtering? In collaborative filtering, there are actually two different types of collaborative filtering. One is user-based collaborative filtering, and other one is content-based collaborative filterings are there. So there are two different types of collaborative filtering. So actually, what we are using in our today kit is user-based collaborative filtering. Okay, I'll be explaining you both the types. What is user-based and let's say content based. Okay, so first thing is, what is collaborative filtering? So using a family of algorithms which is known as collaborative filtering, it is possible to discover comparable individuals or products and generate the results based on the ratings of the user. Okay, why actually, this collaborative filtering is some methodology where we can able to predict someone's interest or some solution, some results based on the previous past histories. Okay, let's in simple term, what is user based collaborative filtering? Let's say A and B are two persons. You can see it in the diagram. A and B, there are two persons who has the similar interest in the past. They both, let's say they both likes some heroes movie. Okay, let's say they both like some Rajini movies. They are keep on liking some of the Rajini movies. So in the future, let's say the person A has liked the movie again, which is released newly by the same actor. But B has not yet seen this movie. He has rated that movie for 5 star, and this B person has not yet seen the movie. He didn't give any rating for that movie. So what is the solution, or what is the conclusion that we can draw from this is, So from the history or from the past, we can able to see that both the persons has liked all the Rajini movies and given all 5 stars, let's say 4 to 5 stars for all the movies. So we can conclude that in the future also, if the person A likes some movies and the person B also likes the same movie, so that is the kind of conclusion we can able to draw from this. So that is what user based collaborative filtering. Okay, so that is also I said content based collaborative filtering. What is this content based collaborative filtering? The Here in content based collaborative filtering, it's not deals with the two-person, it's going to deal purely with one single person. Let's say I will take myself as an example. Maybe in some of the movies, I have seen it, maybe twice or thrice, and I have rated the movie 5 star. Okay, so the movie recommendation system, by default it is going to giving me some other movies which is related to this same kind of a genre movie, or let's say I'm liking thriller movies, it is going to recommend me more on thrillers. Okay, so that is called as content based collaborative filtering. I've told you two different collaborative filtering. One is user based, another one is content based. What's user based? Let's say you and me are liking some films in the past, so there is a chance in future also when I like some movies you can also like that same movie. So that's user based collaborative filtering. And there is something else which is called as content based collaborative filtering, where if I like some content, some kind of a genre, then the movie recommendation system is going to give me same kind of movies which is in the same genre. Okay, so that is your let's say it is your content based collaborative filtering. So let's get into the detail. So the data set that we are going to take for today's session is that is your movie lens data set. So this movie lens, it has the movie recommendation services, which has more than 1,836 ratings, and it has 3,683 tags across some 9,742 movies are listed in that database. Okay, and the data was created by some 610 users based on their dislikes, and then what is their rating on the movie, and all that data has been collected and stored into a single database. Okay, and the user, we are selected at the random of the inclusions, and all the selected users had rated at least 20 movies. So each and every user has rated at least some 20 movies. And then no demographic information is included, and then each user has represented by an id. So every user has been represented by id only, no other information is provided. Every movie is also having their movie id as well as their movie name, and the user has been not given with a name, the user has given only the id. Okay, um, and somebody is asking me, I'm only watching the english movie, so the recommendation systems will work properly. Actually this movie lens is a data set which has been designed for the english movies only. It has not nothing to do with the tamil movies, so we can explore this for sure. So the data are contained in the files which is links.csv. When you download our kit, no, so by default all these csv files will get downloaded into your systems. You can able to go through that, so which has links.csv and movies.csv, and it also has ratings, tags, like that. It has multiple csv files. That is what we're going to explore today. Okay, next, pandas helps you to explore. So what word pandas helps us to explore? So how many records in the frames has? So how many data frames, or let's say what's data frames, every rows and columns, and how many data frames the record is having, and how many elements are there, and let's say how many columns are there, what are all the types of column. Every column has different data types, right? Let's say if you have a name, it is going to be a string. If you have a date of birth in one column, it is going to be a date format. If you are having a phone number, it is going to be a number format. So like that, every single columns is going to hold some mm, data types, isn't it? So what data type that the column is holding, so all such informations are going to be identified with the help of this pandas. So next we'll get into the pandas data frame. So here, two-dimensional size mutable tabular format. That's what data frame we call them. And data is arranged into a rows and columns in a data frame. So when we talk about this CSV files or Excel files or any kind of a tabular format of files, so it's going to be in the it is being arranged in the rows and columns, isn't it? So rows and columns, every file will be in the format of rows and columns. So the data rows and columns are the three main parts of your data frames. One is the data, next is the rows and the columns. So these are all the main part. These three are the main part in your data frames. Okay. So let's see how first initially read your file. So once we read your file, which is available in your system or in any way store in your system, and then only we can able to process it, right? So first we have to load the file into the program, then we can able to let's say filling the missing values, sort them up, and display only first 10 values, display only the last 10 values, or we can able to merge the values, or any sort of things can be done. Any kind of operations, any data manipulations can be done only when we load our file into the system. So that how to load your files. Okay, so first, read CSV file. So df is for your data frame. So data frame is equal to pd is your panda, and then dot read. So pd dot read, that's what you can do. Underscore what type of file you're reading. You're reading your CSV file. So pd dot read underscore CSV, followed by, within the brackets and within the double quotes, you can have your dataset dot CSV. That is your complete file name, your CSV file name. Okay, so by writing this line, you can able to read your CSV file. Suppose if your file is in Excel format, so how can you do that? So data frame df dot to underscore Excel, and followed by the name of your Excel file. So name of your Excel file, let's say data.excel, then you can able to give that name within the double quotes or single quotes. Next, read any other formats, let's say JSON format or anything like that, then we can able to use it df.to underscore JSON, and then within the brackets we can have this data.json, which is the complete file name. Okay, so this is the three different ways how we can able to read different files. So once we reading once the reading procedure, reading your files is done, then we can able to process them, isn't it? So once the reading the different files, let's say CSV files, Excel files, or JSON files has been completely done, then we can able to process them. How can we process them? We can able to just see what is the top of the file, what is the bottom of the file, or any kind of operations we can able to do it. Okay, so sometimes if you wanted to see just first few documents, so then what we can do, we can able to use these kind of df.head. So it is going to just list all the topmost files, and then we can also see df.tail, which is going to give you the bottommost file. So this is the same kind of data set that we're going to use in our today's session as well. Next, data frames. So data frame, selecting a rows. So how can we select a particular rows? So you wanted to specifically select some of 10 rows or 5 rows or 20 rows I want, or 50 rows I want. So how can we do that? So in order to select, if you need to select a range of rows, we can able to specify using this colon symbol. So how can we do that? Data frame followed by starting, where we have to start and where we have to end. So let's say start from 0 colon till, let's say, 10. So we can able to get all these first 10. So we have to specify the starting range and your ending range. And then we can also see this and different data types. I used to tell you that each and every column is going to have different data types. Let's say if it is a phone number, it's going to be number. You have your name, and that's going to be a text. If you have your date of birth, it's going to be in a date format. So every single column is going to be in a different data types. So how can you see the data type of some columns? So we can able to see it with the help of dot d type, data type. Okay, so for that we can use df is your data frame, and which column you wanted to see, and that title you can give it, and followed by dot d type. So when you give that, and it is going to return back what type of data it is. So if it is an integer, then it is going to give integer 64 bits. When it is float, it's going to be float. Or if something is an object, then it is going to give you object. So in that way, you can able to find what type of data it is, what type of data type that each and every column is holding. And we can see some of the methods. So before that and all, we have seen how to first let's say include your files into the program, and we have also seen some how to see their data types of each and every columns. Now we can see what are the different methods we have. So the methods and all, we can able to, in general, we can say df, it's a data frame followed by the name of the method, what method name that you're using. So that method you can able to give. So, and it also have some parenthesis, so that we can able to pass some arguments to that. Based on that, your method is going to execute. So whenever it's obvious, no, whenever we call a function, or whenever when we define a function, we'll have to have some parameters which is enclosed within this parenthesis. So we can pass some arguments. Based on that, the function is going to work. So we can use merge, we can use unique, and we can use extend. These are all some of the inbuilt functions that we have within your um, data frame. So you can see here we have head and we have tail. So head is going to be produce some n number of files from the beginning. Let's say I'm saying head of 10. So it is going to give me some top 10 rows or columns. Let's say top 10 rows I wanted to display. So that information is going to display for head. Let's say if it is a tail, so then it is going to produce me some bottom files, bottom 10 files. So that is going to be listed. And then we can also give describe, we can able to do min max, we can go with the mean, median, we can give standard deviation, we can give some sample data. Sometimes you want some random data from the entire database. Maybe you have some let's say some lucky draw. So out of this 10,000 students, I wanted to select some 3 students for a lucky draw. So I can use this random, sample function, which will generate me some random roll numbers. Let's say roll number. I'm going to search based on roll number. So it is going to generate some sample random roll numbers out of this 1,000 students. So I can able to select. So for that purpose, we can able to use it. And we have maximum, we have minimum. So max is something that we can able to return the maximum value in the available data. Minimum is a minimum value. Mean is the average kind of a value. Again, medium, standard deviation, sample. And this drop na is going to drop all the records with missing values. So whenever we have the missing values, you wanted to drop all the missing values, you wanted to have only the complete details, you wanted to drop all the null values, missing data and all, you wanted to process only the complete data. In Then it is actually difficult for us to go through all the columns and rows what all the data are missing and how we have to delete all the missing values. Manually, if you do that, it is going to be a huge time taking process by just seeing what all the data are missing and to delete it. So in order to make that process automatic, we have this drop NA, which is going to perform the same operation. It's going to go through what are all the null values that we have and completely remove all these null values, complete data. Okay, guys, that is drop NA. So here you can see with the method we have LOC. Here you can see we need to select the range of rows using their labels. So we can use this LOC function by just mentioning their name and the range. So you can see this one example, movies.dataframe.loc starts from 10 to 20. You don't want top 10 or bottom 10. Specifically, you're saying that you want to start from 10 and you want to end up with 20. And what you specifically want is you want the title and you want the movie ID and also you want the genres. That's the three information you want. Maybe your data set can contain more information than this. It can also have, let's say, movie ID, it has, and it can also have the ratings information. It can also have the year of release, something like that. It can have some more additional information. You don't want to see all of the information. What you wanted to see, you wanted to see only the title, you want to see only the movie ID, genres, that's it. And that too from 10 to 20. So it is going to be that specific. So you can able to have that specific information when you wanted to see some specific data. So here you can see we need to select the range of rows and columns using their positions. We can use this LOC method. We can use df.iloc starts from 10 and ends from 20, and we can able to start again there specifically where it want us to start, and all that detail you can specifically mention and you can see their output. Again, you can see in much more specific manner. Let's say if this data frame.iloc, if it is mentioning 0, so it is similar like your arrays in C programming. So when I'm saying that it is array of 0, where we are locating it? Anybody? When I'm saying array of a of 0, so which element it is going to access? Yeah, it is going to access the starting element. Okay, first element in an array. In the similar way, if I'm saying it is data frame and dot iloc 0, it is going to fetch the first row of the data frame. Let's say you wanted to fetch the last one. So if you wanted to fetch the last one, you can say it's -1. Then it is going to be last row. Let's say if I'm saying array of 1, it is going to be the second element. If I'm saying array of -2, it is going to be the before last element, second last element. Okay, so that's how we can able to relate your data frames into arrays. It's similar like that only. And suppose specifically you wanted some nth element or ith element, then we can just use I as a number. Then you can able to print that I plus 1 because it's starting from 0. So when you wanted to see some element, then you can able to specify their specific numbers. And suppose by default you didn't mention anything in the starting, it will just by default it will start from the beginning. Sometime if you didn't specify your ending element, by default it is going to take the last as a ending element. If you are specifying your first and last, then it is going to give you the specified values. Let's say in this example 0:7. So starting element you mentioned as 0, ending element you mentioned as 7. So it is going to give 0 to 7, which is first to 7. Suppose you wanted to have only first to 2 values, then 0 to 2. Suppose you didn't mention any starting value, you have given only 20 as ending, then from where to where it will print? You didn't mention any starting value, but the ending value alone specified by 20. Then by default it is going to take The starting is 0 and the ending is given by you, which is your 20. So it's going to give you from first element to 20th element. Sometime you have given the starting value as 20, but you didn't mention any last element, ending element. Then where it will go? Up to what it is going to print? So it is going to print till the last of the data frame starting from 20. Okay, guys. So by this way, we can able to print some values in the data frames by just starting or ending or something like that. And we can also process sorting. So absolutely we can able to do sorting. So how can we do sorting? Let's say data frame sorted is the new variable name that I'm using, that is equal to data frames dot sort values is a default function. So we can use the sort values on the how you are going to sort either movie, because there is lot of columns are there. Based on which column you're going to start sort, let's say either alphabetical order, or you're going to do sorting in the number based descending order, ascending order, or any, and which way you wanted to do it. Okay, so that you have to specify. So I'm saying that I wanted to rate, I wanted to sort based on the ratings. I can give you a simple example. When you go to when you go to this any of e-commerce websites and all, there is an options for sorting. um, Sorting either we do with a high rating, or we can sort with relevances, or we can able to sort based on price low to high, price high to low. We always give price low to high, no? So we can able to sort based on our preferences. So that is one of the different sorting methods that we can use it in our data frame as well. So for that we can use data frame dot sort values. So now we can able to go to our candy kit and show them, um, show how they are working. I'll be sharing my screen. So I think if you are doing it along with me, guys, you can see that, yeah. So this is what the kit setup that we have done. So it is asking me, you wanted to run the kit? Yes, I'm saying yes. Enter. It says kit is starting. It will automatically redirecting me to the Jupyter notebook. So you can able to see this. Yeah, the complete program has been executed for us. So you can see this movie recommendation system for us. So here there are the two famous library that we have used for this particular program is NumPy and Pandas. These two libraries that I've used. So how to import these two libraries? Import NumPy as NP. So this is a syntax, or we can say this is your code lines that you can use for importing them. So import pandas as pd. So this is you can use for importing your pandas library. And then we are going to link your data set. So how to do that? You can just open it first. So you can say that link pdf data frame is equal to pd dot read cv. I also told that how, what are the different ways to read your csv file, read your excel files, read your json files and all. So same method we can use it for reading your csv file. So our csv files are there in this name. What is the name? Data underscore links dot csv. So that complete file we are reading it. Okay, and what is the operation that I'm performing? This is my name, whereas links dot df dot head. What is this head method is going to do? I'm just zooming a bit. uh, you can see what is this head method is going to do. I told that by default it is going to print the topmost 5 values. So that's what this head method is going to do. Let's say if you wanted to change that into some topmost 10 value, then you have to say that 10, then 10 values will be listed. Let's say I wanted to do some 20 values, you can say that, so that it can give you some top 10, top 20, but by default it is going to print top 5 values. Okay. Next, what are the other thing that we can, basic operations. Let's say movies.df. So this is some of the other file. You can see the first file that are with the name of links. So links is the first CSV file that we have it. When you set up this entire kit, you can see the whole data set collection which is be stored under this data folder. So inside this data folder we have links.csv, we have movies.csv file, and we are also have some two more files, which is rating.csv, tags.csv. So these are all the 4 files which is already stored in the kit itself. When you install the kit, those data sets are automatically installed in your, or it is downloaded in your system. Okay guys, so first we did head method. It is going to just display the topmost 5 values by default. So next we have just opened some other file which is movies.csv. So in that file also I'm just displaying the topmost 5 value, which is movies.dataframe.head. It is going to just list all the topmost 5 films. So you can see that Toy Story, and then Jumanji, and we have this Old Man, and Waiting for Exile, Father of Bride, and Part 2, and all this. And what all the different genres that they coming on adventure, and it is comedy one, like that we can able to see what genres those movies are coming under. So these are all some of the columns names that my CSV file is having. So it is displaying as it is. And next, I'm just opening my rating.csv. So in this rating.csv, I'm having only the movie's ID, user's ID, which user has rated this movie. No, so user ID I'm having, movie ID I'm having, and then rating I'm having, and the timestamp I'm having. So this complete information are stored in this rating.csv file. So in that rating.csv file, you wanted to print only top 5 values, head values. If I'm just giving, instead of this head, if I'm giving tail, it is going to print only the bottommost 5 values. So I'm just giving its head, where you can able to see the topmost 5 files and their user IDs, movie IDs, ratings, timestamp, and all that. Next, I said I'll be having one more file which is tags.csv. So you can also see the topmost 5 values in that. You have movie ID, and then user ID, movie ID, and tags. What is the tag? Hashtag or something like that. It is going to be a funny kind of a movie, or it is going to be some headline about the movie. It is a boxing story, or it is let's say this is going to be a sentimental movie, like that. What are all the tags for that movie, it is going to be given along with that. Okay guys, so these are all the basic different files that we have it in our system, and we just try to print the topmost value. Now only we are getting into this movie recommendation. So how we are doing this movie recommendation, I even said that if a person A, I told there are two different types of movie recommendations are there. One is user based collaborative filtering, and other one is content based collaborative filtering. What is user based collaborative filtering? If a person A is liking some movies, let's say movie number 0, 1, 2, 3, like that, if the person B who's likes one or more movies, let's say which is there in the common list, okay, so we can say them as M of J. Then in some of the other future in the history, they have their interest in common. In future, person A has given some interest, person B has not given any value, but we wanted to fill that value. So how can we do that? So we can able to just take it from the person A itself, because in the history or in the past they have their movie list in common. So that way we can able to recommend for this person B by the interest of person A. So that is the kind of collaborative filtering which is based on users. So that can be done. And there is also one more collaborative filtering method which is content based, where if you're watching some movie which is in some similar content, and those thriller movies, those kind of comedy movies are again going to be recommended for you based on the content or the genres. So that is one thing. So now you can just open this. Df is equal to, you can say that what we are going to do is we're going to merge these two data set. What we actually have is, we have, you know how we are going to match what is the specific value. Based on that we are going to merge. I even told you an example that there are some second year students and there are some third year students. I wanted to merge both of their data set, where I'm going to have some a common program for second year as well as the third year. So in order to do that, so what I can do, based on let's say their department, because the department is going to be common for second year and third year. I'm going to have the computer science department second year students as well as the third year students. It's going to be common, no? So based on that I can able to merge them, so that I can create a complete list and I can able to apply the new program to them. So in the same manner we can able to merge two different data set based on movie id. So once I did that, then if some person has their movie recommendation, and if some other person have not their movie recommendation, just we can able to, after merging them, we can able to sort them. And after that, based on the user's id, if any of the other user id value has not given any of the recommendation, if it is false, then we can able to recommend the movies based on their history. Okay, so you can able to see here, you can able to see here, there are some movie recommendations for a person A to B by just comparing two different data set for movies. In the recommendation movies, we can print all of the movies. When we combine two different data set, we can say that these are the sum of the common list based on the movies id. When we merge two different data set, and that time we come up with these are all the common movies that they two different data set is having. One data set we had it with the different users, and two other data set we had it with the different users. When we merge based on their movie ids, we can get these common recommendations. So we can able to recommend these movies for these users also. So we can able to recommend these movies for the other users also, because how we are concluding this, in the history they had some similarities. So that is the only thing. Based on that we are just predicting they must be liking this as well. Okay, so this is what we are doing with this movie recommendation systems. Now we can also see, the movie recommendations with let's say some weightage. You wanted to see some rating as well, we can able to see the highest rating. You can see based on the rating also we can able to recommend to the user. You can say more than 4 or 5. If the rating should be greater than 4 or 5, then we can able to rate those specific recommendation movie to the other user. Okay guys, so it is as simple as that. Let's we can go and explore some of the exercises. So here we can see there are three different exercises. One is how to join the data frame. So how to join it? I think it's very simple. We can also use, we already use this merge function. We can able to merge data frame 1 into data frame 2. And how to merge it? We can use this cross functions to merge it, and we can reset their index. So once we merge, we can say that the index needs to be reset. So from the data frame 1 what all the values are there, and from the data frame 2 what all the values are there, we can able to join them and reset their index. So it's as simple as that. We can copy this code, and you can able to post it in your Jupyter notebook, and you can run and see the output. And next, we can also sort pandas using data frames. You can also do sorting procedure. Yeah, you can see in this particular example, let's say, yeah, I'll zoom a bit. Here you can import pandas at PD, and we can say the data frames. Let's say the first data frame is going to contain some values, other data frames are going to contain other some values, and after this we can able to sort. For sorting, what function we can use? Sort underscore values. This is what we already used in the program as well. So sort underscore value is a default function that we can able to sort it. So that also we can do. And third code snippet that we have is how we can able to remove the duplicates. You can see over here, you can copy it, and you can able to paste it in your Jupyter notebook and see the output. So here, if you can see in this data frame, column 1, you can see there are two duplicate values, cat and cat. And in the column 2, you can see there are duplicates, bat and bat. And in the column 3, there is no duplicates. So you can able to remove those duplicates. So after removing that duplicates, you can able to print their results. Like the cat should be printed only once, and the bat should be printed only once. So that procedure we can able to do it. Okay, so these are some of the application that we can able to how to we can do this, you know remove the duplicates with the in default function, which is called as drop duplicates, drop underscore duplicates. Already for sorting, we did sort underscore values. So with the help of that, we sorted. And if you wanted to drop the duplicates, we can say drop underscore duplicate. So with the help of these function, you can able to drop all the duplicate function. So there are much more interesting code snippets are there. You can just go through and experiment all of them to get more insight about this data science libraries and some coding and all. So I repeat, guys, in order to record your attendance, there is no any separate attendance marking system for this program. Only that you have to log into the system and watch this live video or recorded video. So your attendance will be automatically marked. And about this coding projects, so you have to click on this coding project and you have to attend the questions. And if you just attend, um, you know you have to attend all the question. From the question 6 to 10, you have to upload only png format. That should be in a descriptive way. You have to read the questions and execute the program, record the result, take a screenshot, upload in a png format. So in order to get the badges, you have to get 60% of the correct answers, which is 6 out of 10. So within 48 hours you will receive your badges. Suppose if you didn't pass through this evaluation criteria, then you will be receiving a mail stating to retake the assessment. Again, you can come here, you can retake the assessment, then you have to be eligible for getting your badges. So I will quickly go through some of the questions that the students are asking, and I will try to answer the course questions. So I can see some of the students are asking that what is the purpose of df dot group by. So this df dot group by is a pandas basic default function that is used for grouping the data based on one or more variables for aggregation. It's basically used for aggregation purpose. Okay, and I could see some of the other students are asking that which function is used for dropping the rows. Yeah, dropping the rows, we can use df dot drop na. So we have already seen, I think, when you wanted to drop all the null values, then we can able to use df is a data frame followed by dot and drop na. So by just using these default function, you can able to drop the values. So okay, guys, so any other questions? Somebody is saying Candy is not opening for me. It must be opening. Check your internet connections. If we are getting trouble, just delete the entire download that you have done. Re-click and download, and then unzip that. Click on the batch file. You will get an error. You are getting an error. It shows that I'm getting an error. No, I was doing it in front of you only. So when I'm clicking on the one click installer, it's have to get download. Sometime it may ask you run anyway, so you have to click on run anyway. So run anyway, and then it will take you some time. It will take you some time, and then it is asking you yes or no. Then the kit is set up into your system automatically. How to download the dataset? The dataset will be there in the file, so you can go to the C drive, and you can see there will be Candy Kits folder. Inside that, this particular folder will be there, what which you downloaded for today. And if you explore that folder, then you can able to see this dataset which is already present in that. Okay, anything else, any other doubts? So if you have no doubts, let's look into the calendar. So this is your calendar, where for today's session, the deadline for submitting your assignment is going to be September 2. So that is your week 2 assessment deadline. And from the week 3, just be we are going to explore Studio, where we are going to develop our own application in Studio. It is going to be excited, and you're going to do your capstone project, and you're going to complete your courses on week 3. So stay tuned for the next week, guys. Thank you.